Here we study one more application of fundamental theorem of arithmetic. The question here is that prove that this number and this number both are composite numbers. That's what we are trying to prove here. One way of, okay, let's understand the definition of prime number and composite number. So what are prime numbers? Prime numbers are those numbers which are not divisible by any other number apart from itself and 1. So that is prime number. Composite number, opposite of prime number, which means there exists a number which divides that number, correct? So in order to prove that these are definitely composite numbers, one thing that you can do is you can multiply these 3 and add with 13. If I give you like 10 numbers and then give you one more number, then you have to multiply all the numbers and then add and then find if there exists any number which divides this one. It's a painful task, correct? So all our task to prove that these two are composite numbers is that we need to identify at least one number which divides these two, correct? So that's all we are supposed to do. So we have to find one number which divides these two. So let's see if there exists one number which divides these two numbers, alright? So how can we write this one? So if you see, if you multiply and then add and you get a huge number, and checking if there exists any number which divides that one is a painful, extremely painful task. Take it from you. You can try it though, but it's extremely painful task. But here, if you see, this can be simplified. So how can I simplify this one? You take 13 outside. So if I take 13 outside, between these two, if I take 13 outside, here it is 7 into 11 plus 1. So doesn't matter what is this one, this is another integer, correct? 7 into 11 plus 1, some answer. Here you get 77 plus 1, 78. So this essentially is 13 into some number, correct? Since it is 13 into some other number, I know that there exists at least one number. What is that number? 13, because it is 13, some multiple of 13. So which means definitely this number is multiple of 13, which means this number is definitely divisible by 13. Correct. Since this number is definitely divisible by 13, this number has to be a composite number. Correct? Alright. And definitely this number is not 13. I mean, this is a huge number, but we found that there exists at least one number which divides this one. That number is 13. And even it is 78. You can even say it is divisible by 78. That is also okay. Correct? So there exists at least one number which divides this number. So therefore, this number has to be a composite number. I'll write that argument for your sake. So this is 13 into some q. I don't care. So it is some integer q. Correct? Since this number is written as 13 into q, the given number is divisible by 13. The given number is divisible by 13. So 13 is neither this number nor 1. So therefore, by definition of composite number, there exists at least one number which divides that, which is 13 in this case. So therefore, given number is composite number. I hope you understood this one. So here also we have to do the same thing. So we have to prove that this is a composite number. So all we need to do is find at least one number that divides this one. So how can I do that one? So we can actually simplify this one. So by simplifying, I mean I can take 5 outside. So when I take 5 outside, so what remains here? So it is 7 into 6 into 4 plus 1. So I don't care. These are all integer multiplied and added with another integer. So this is again another integer. So this is some 5 into some answer q. I don't care what the answer is, but this is some multiple of 5. Because it is some multiple of 5, I can safely say that this number is divisible by 5. So since this number is divisible by 5, it has to be a composite number. Since the given number is divisible by 5, the given number is composite number. Is composite number. I hope you understood this one. This is another simple application of applying fundamental theorem of arithmetic in order to prove that a number is composite number.